Hi there. Welcome to part 4 of our week 5 learning guide to college algebra. If this is the first time you're seeing my face, please make sure it is not the last by clicking that subscribe button. That way you're going to get a notification every time a new video is posted and you can get tons of math content here on my channel. We're going to jump in today with synthetic division and factors of polynomials. And I know that sounds a little bit daunting, but we're going to try to simplify it, make it where it's easy to do. I've given you a very colorful example of synthetic division, but I'm going to walk through the examples we have. Just a reminder about our learning guides, this video is going to only cover these examples. If you would like a copy of this learning guide, I will link it in the description below. That way you can download a copy and follow along with us. I'll also put the links to the other videos for week 5. And just realize the College Algebra Learning Guide actually have weeks 1 through 8. So lots of good math content, math examples for you that are hopefully going to make that college algebra class just a little bit simpler. So let's jump right in with number 1. We're looking to divide this polynomial by x plus 2. And friends, just for a little bit of space, I'm going to bring in an extra piece of paper here for this particular problem because I don't want to run out of space. So when we look to do synthetic division, the first thing we have to do is to take what we're dividing by, x plus 2, set it equal to 0. You can then go ahead and subtract 2 from both sides. You'll get x equals negative 2. You need that negative 2 to put in our synthetic division. And I like to put it in a box here, kind of sets it aside. Reminds me of that good old division sign we are all familiar with from elementary school. Now, the next thing we need are the coefficients of each term in the polynomial, meaning I need the 3, I need the 4, I need the 1, but I also need to recognize that we skipped a power. So instead of just 3x cubed plus 4x, we actually have to consider that there is a 0x squared term. We need that as a placeholder. So when I write those here, I'm going to write them with the 0 as a placeholder. Now, a lot of this is going to sound familiar with the processes that we learned with division, okay? But they don't go in the same order. So the first thing we do is to bring down. So I'm going to bring down the 3. Negative 2 times 3 would give me negative 6, and I write it here. Now we add. 0 plus negative 6 is negative 6. Now we multiply. Negative 2 times negative 6 gives me 12. Now we add. 4 plus 12 gives me 16. Negative 2 times 16 gives me negative 32, and we add. Now, I want you to recognize a couple of things. When we get our answer, you can guess our answer comes from this last row, but our answer begins with the degree less than, so the exponent less than this one. So our answer is going to begin with x squared. 3x squared minus 6x plus 16. So what does the negative 31 mean? That's our remainder. Okay, and just like when we were in elementary school, we write our remainder as a fraction. We put it over the divisor, which was x plus 2. So the quotient is here, and our fraction is carrying our remainder. Okay, very similar to what we did when we learn division this way. It looks a little bit different with polynomials. So if you need to go back and watch through that again, really look at where we bring down, we multiply, then we add. Then we multiply, then we add. And you'll want to make sure you get those all in the right places for your division. Okay, let's look at number 2 then. For this one, I'm going to factor, and I notice that I have a number in front of x squared. So I'm going to have to be real careful. When we say factor, we want to answer with 2 parentheses. So we're going to factor trying to think about the FOIL method or the distributive method. So the first thing I ask myself is what times what would give me 2x squared? Well, that would have to be 2x and x. What would multiply to give me negative 25? Well, that would have to be 5 and negative 5. I'm not real sure where the negative needs to go. So I'm just going to put the 5s in there and we'll see what happens. Now, if we did our inner and outer products, so if I multiply these two, I'll get 5x. If I multiply these two, I'll get 10x. Now, in order for these to add to give me 5x, the 5x would have to be negative. In order for that to be negative, there has to be a minus sign here and a plus sign there. So now I get 2x minus 5 times x plus 5 as my factored form of this. Practice with your factoring. The only way to get better at factoring is to practice all of those. Okay, number 3. Is x minus 3 a factor of this polynomial? This one's a little bit more difficult to factor. So here, let me translate this question for you, saying, is the remainder 0? Meaning, if I can do synthetic division here with x minus 3, and I get a remainder of 0, then this is a factor. Okay, so let's do another example of synthetic division. I'm going to bring my paper back over just because I want to have more room. Remember, the first thing we do is take the divisor and we set it equal to 0. So x is 3. Remember, we're going to put that in a box by itself. And then we're going to take the coefficients of the terms. Did we skip any powers? Doesn't look like it. So we'll write those coefficients. Now, remember, we bring down first. So we bring down. Now we multiply. 3 times 2 gives me 6. Negative 4 plus 6 gives me 2. Multiply. 3 times 2 gives me 6. And add gives me negative 4. And multiply and add. Now, where is your remainder? Your remainder is right here. Does it equal 0? No, it does not. So that means that x minus 3 is not a factor. So remember, when you're looking for it to be a factor, you're asking yourself, does it have a remainder of 0 when you divide? And that synthetic division is going to make it super simple for you. Okay, friends, one last problem here on part 4 of the week 5 learning guide to college algebra. For this one, we're being asked, what is the maximum number of zeros that this function could have? And our zeros, the maximum number that you can have is always your highest exponent. Does that mean you're going to have 5 zeros? No. It just means that you could. That is the most you could have. You couldn't have 6 of them. So I hope that helps with this part of our learning guide. Like I said before, I'm going to link the other parts of the week 5 learning guide so that you can access them below in the description. And thanks so much for watching. I hope this helped. Bye-bye for now.